So what we can do here is this. Chelsea's trying to measure the width of a river, okay? And she's marked out the following diagram. So basically she could walk along the bank and measured 17.3 meters and then decided to stop and then measured another 3.2. And then she would have walked 7.5 meters away from the river, right? And she's basically set up this diagram. In attempt to...
Can't see your screen, sorry.
Oh, sorry. That's good to know, I suppose. There we go. Okay. So anyway, there's your diagram. Okay, so just again, Chelsea walks along the river, right? She's trying to measure the width of this river, right? So she walks along 17.3 meters, then walks another 3.2, and then walks 7.5 away from the river, right? And she sets up this diagram. An attempt to figure out how wide the river is. Okay, that's what X is. So what you can do from this picture, or if it's given in the words, I would draw the big triangle where the base. I'm just going to redraw this, but with two separate triangles so that we can see. Okay, so I'm going to say the width of the river is going to be X, right? And then the base, along the bank, is going to be 17.3 meters. Okay. And then, additionally, she would have measured another little triangle, right, of 7.5 and 3.2 meters. Okay. So those are your two triangles. Side by side, you'll notice I've put the right angle in the bottom left corner both times, right? So I've rotated this top triangle around just to make them look the same. Okay, and then you just use the process we used this morning. Okay. So what I like to do is just set up a proportion, right? It looks like it looks like eventually I'll be going from the small one to the big one. Okay, so we can do this two ways. We can say, let's figure out what the scale factor is, right? And the scale factor would be, okay, we got to figure out, which two side lengths do we have on both triangles, right? Where do they match up? Well, it looks like we have both bases of the triangles. Okay, so we can figure out what the scale ratio is between those two, right? Okay. And then you could figure out, okay, well, what is 17.3 divided by 3.2? That would give you a number, right? That's the scale ratio. The way I prefer to do it is a little bit I just like setting up the ratios and solving, okay? There's a little bit less thinking that way. So I like just setting up, okay, similar triangles. Let's go, okay, 17.3 over 3.2. That has to be equal to, well, 17.3 was a part of the big triangle, so I'm going to take side length X because it's a part of the big triangle as well, and that's going to go on top. And I'm going to divide that by 7.5. Okay, your only job at this point is to solve for X. And you'll see what I've done is I've put similar side lengths, one on top, one on bottom. Okay, and I always try to match tops and tops and bottoms and bottoms. Okay, so I try to get 17.3 and X both in the top because they're both on this big triangle, right? And then I try to match up the bottoms, which will be the 3.2 and the 7.5. Okay, 3.2 and the 7.5. Okay, they're both on the bottom because they both come from the small triangle. Okay, once you get this set up, I just like setting it up this way because now it's just we can use Actually, we don't even have to do anything. We could do just the math on this. Figure out what the number is. Well, what's the number? You type it in your calculator. Right, you go over, we gotta launch it again. Right, I could just do the math on that and say, okay, 17.3 divided by 3.2. That's 5.4 is equal to x over 7.5. How do I get x by itself? Multiply both sides by 7.5. Right? 7.5 cancels 7.5, and you're left with x equals 7.5 multiplied by 5.4. So we take that answer, 5.4 multiplied by 7.5. It's 40.5. meters, right? Because this is a word problem, I would like to see, therefore, the river okay. Okay, what I can do here is finish this off too, okay? You'll see that we get the same number twice. If you figure out 17.3 divided by 3.2, I have to pull the calculator back up. Okay, again, we see it's 5.4. We talked about what that was earlier this morning. We see that pop up right here. Right? Now, you can think of the fact that I'm going from the small triangle to the big one to figure out what x is. Okay, so you know what your scale factor is. It's 5.4. Right? So if you're going from the small to the big, the only way to do that, or the order of operation that works for that sort of scenario, is to multiply. Okay, if my x was on the little triangle instead, like let's say for instance, I was coming back the other way for whatever reason, if I knew a different side length, then you would divide by 5.4. Okay? Does anybody have any questions? This is just using similar triangles to solve some word problems, okay? You guys should be able to go do, I can do one more. I have one more planned here. And I can give you guys, you can go look at your homework questions, okay? Later, okay? So here's a scenario, okay? And I suppose like a scenario where this might be like useful would be like, let's say you're in like, I don't know, you're working on outside of houses and things, right? Or you needed two ladders, two different ladders, which you see sometimes driving around town, right? You see people with these vans with a couple different ladders on there, right? Let's say you got one particular job and like you want to know which ladder to grab off the truck, right? Well, you kind of need to know how far up you need to go, right? Because you don't necessarily want to haul the big one to a little job, right? And so like you're trying to figure out before you even get the ladder off the truck which one you're going to pick, okay? I don't know, I'm just making up a scenario. All right, so you've got these two ladders. They're leaned up against a wall so that they make a right angle with the ground, okay? So you're going to have, they both make a right angle down here, okay? So essentially what you've got, if I could draw on this picture, you're going to have, or I'll use a highlighter so you can see. We're going to have one triangle here, a small one. Then you're also going to have a bigger triangle, right? So you got two triangles. Okay. So it looks like. I'm just going to draw these two triangles that are created down here, okay? It's going to be a small one. Okay, and we're going to have a bigger one over here. Okay, now the difficulty now is just labeling the two triangles, okay? They both have a right angle in the corner. I think we know, just by looking at this, there's a 10-foot ladder and an 8-foot ladder, okay? Well, the 8-foot ladder must be, remember, this is going to be your ladder going up here, right? And so this must be 8 feet. And then this must be the 10-foot ladder, right? So that's 10 feet here. I'm not too sure what it means by 18-foot ladder, though. Oh, sorry, I've mislabeled this. All right, let's restart here. The 10-foot ladder, so this is 10 feet here, okay? That's a little ladder. There's two different ladders, sorry, I'm just not reading. There's a 10-foot ladder, and there's an 18-foot ladder. Okay, so the big ladder is 18 feet. Okay, and then it says the 10-foot ladder reaches 8 feet up the wall. Okay. All right, is everybody okay? I just didn't read the question. Okay, you just gotta be careful, I suppose. The question asks, how much further up the wall does the 18-foot ladder reach? Okay, well, we first need to actually figure out how far up the wall the 18-foot ladder can reach. Okay? And so we can use our similar triangles here, right? Because it looks like, just by looking at this and this, you know two of the like shared side lengths. Not shared side lengths, but similar side lengths, right? The ladders. One's 10 foot, one's 18 feet, right? Additionally, it tells you, okay, well, I also know 8 feet, and I want to know this. So this looks like, just in the way that I've set these pictures up, I can solve for what x is, okay, using my similar triangles and my scale factor, or ratio setting up, right? So what I'm going to do is I'm just going to go, okay, 10 over 18, right? That has to equal, the 10 came from the little triangle, and so I'm going to put the other side length from the little triangle in the top over here, 8 over, what's the thing I'm trying to find? X. Okay. So, why don't you guys just give me a number? I'll do this question two ways too. I just want to give you guys as many different ways to do this as possible, okay? So here's the first way. We'll do it the normal way that I showed you before, and then I'll show you one other thing, okay? And we'll see if we get to the same answer. Okay, let's get a number for 10 over 18. Okay, that should be 10 divided by 18. We could just type it in, which way you guys are going to do. 10 divided by 18. We'll call it 0.56, okay? That's going to equal 8 over x. Okay, you got to get x by itself. That's the whole goal. Well, how do you do that? You can multiply both sides by x. Okay, which would cancel the x's on one side, but you still don't have it by itself yet. Okay, so you're going to still have 0.56. X is equal to 8. Well, you can divide both sides by 0.56. And now, x is by itself. Drive me nuts. Okay, so we just got to figure out what the answer is. 8 divided by 0.56. call it 2-3 meters, okay? All right, so how much further up the wall is the big ladder able to reach? Well, it looks like we'd just be able to go 14.23. That's how far the big one reaches. And then we subtract off the original 8 feet, or the 8 feet from the small ladder, right? That answers this part. How much further up the wall does it go? Okay, so then you guys just type that in your calculator. Right, so 14.23 minus 8. Done. Okay. Therefore, the ladder, the big ladder, okay, it'll be okay. I'm gonna do the same question here using this. Okay, after we've set up the ratios, I'm going to show you how to do it a different way that maybe some of you don't like this solving method from here down, okay, from all this stuff here. Maybe you don't like this. I don't know. Okay, I'm going to show you an alternative way to do this. It's the same every time, okay. I'm going to rewrite this. I'm going to do it in red. You'll see we'll get the same answer of 14.23, okay. Once I set up the ratio like this, right, I don't think there's really much way of getting around this, unless you wanted to do the scale factor way that I showed you. Okay, once you've set this up, we can do this thing, and maybe you guys have seen this in grade 9, okay? This might be a flashback, I'm not sure. We can do this thing called cross multiplication. Okay, all that means is I physically multiply the two numbers where the arrows meet. Okay, so 10 times x is going to be 10x. And that's going to be equal to 8 times 18. Okay? Now you can do the math here, right? So you're like, okay, well, there's no math to do on the left side. I don't know why my calculator keeps closing. There's no math to do over here. It's just 10x, right? But you can go 8 times 18 and get a number, right? That's 144. So 10x is equal to 144. Okay? Then you can go, okay, I just need x by itself. Divide both sides by 10. Okay? Why are our answers different? This is an important kind of discussion. Our answers are different because if you remember, 10 divided by 18, we rounded this number, right? And then on top of that, we used that rounded number, the 0.56, we used it again here. And then I rounded this answer. Okay, so we're a little bit off. Not a lot, but a little bit. Okay? You come down here, you see 14.4. I didn't do any rounding down here until my final answer. Because I didn't do any rounding in the intermediate steps, my answer is probably a little more accurate in number 2 relative to number 1. You can see it, right? 2, 3 versus, this will be 0.40, right? Okay, and then you just do the math again, just figure out how much further up the wall it made it, right? Okay, that does it for similar triangles. Okay, again, you can kind of see the emphasis on just it being able to represent word problems, but just drawing pictures and solving them with your like the processes I just showed you. Okay, it's all about setting up the fractions or the ratios, and then you can cross multiply like what I showed you down here. Okay, or you can use the process up here. Okay, so if there aren't any questions, I'll hit stop here. Okay.